What's up, Algebra 2? Here we are with 4.7. Why are we jumping to the end of the chapter instead of at the beginning? Because we're focusing on the graphing part first. And this graphing part today should fit nicely or relate nicely to your absolute value graphs. And that's what we're starting with. Okay, remember your absolute value graphs from not that long ago. We have y equals a times absolute value of x minus h plus k, where the a on the outside was your slope, kind of. Inside, the h would slide your starting point left and right, and the plus k on the outside slides your starting point up and down. So let's rewind it back to absolute value. So the minus 3, remember they're opposite on the inside. Minus 3 goes 3 to the right. 1, 2, 3. And the minus 5 moves my starting point 5 down. 1, 2, 3, 4, 5. Okay, that's the starting point for my V. And then 2, we said it's kind of like the slope because it's up 2 over 1, but it's up 2 over 1 both ways, because the absolute value makes a V. Alright, and then we draw our line. Okay? Now, our x squared graphs that we're doing today, graphing quadratics, x squared graphs in vertex form is going to be very closely related to this. The left and right, the up and down. And it's just that this times 2 out in the front, whatever this is out in the front, is not going to be directly a straight line, because x squared graphs are curved, they're called parabolas. They're curved. Okay, so let's take a look at the original, the basic one, x squared. Okay, I already have a t-chart kind of filled in here for you. Okay, let's start all at the bottom. I guess that'd probably be the easiest way for us to go. 3 squared, because this is our x, and we're putting that in. 3 squared gives me 9. 2 squared would be 4. 1 squared is 1. 0 squared is 0. And here's the tricky part. Negative 1 squared. Negative 1 times negative 1 is still positive 1. Negative 2 squared is 4. And negative 3 squared is 9. Okay? So it's going to be kind of like this. Both ends are going to end up going the same way, but it's not going to be just a solid, sharp, straight line. It's going to have a little bit of a curve to it. So let's start here in the middle. 0, 0. And if I go over 1, 1 squared was 1. If I go over 2, from my vertex, 2 squared is 4. 1, 2, 3, 4. And 3 squared, out 1, 2, 3, 3 squared is 9. We're just going to, I think it's this one, without counting all the way up. Okay? And just like with absolute value, you can reflect it over. Okay? Our parabolas, our x squared graphs, are also going to have a reflexive property that we can reflect it over our axis of symmetry. And we can see that with our points on our t-chart. Negative 1 was 1. Boom, boom. Negative 2 squared was 4. That should match. And then negative 3 squared is also going to be 9. And you can see where they would reflect over. You should also see that we're not going up by the same amount every time. From here to here was 1. Here to here is 3, and here to here is 5. So it's not going to be like a line. It's going to be curved, and it's going to get gradually steeper as we go. So you can take that same pattern if you recognize what I was saying. You know, we filled in the t-chart, but then I didn't really go back to it. Because we're at 0, it's a little bit more natural. If we go over 1, from 0 we're at 1, and 1 squared is 1. Over 2, 2 squared is 4. Over 3, 3 squared is 9. Okay? But once we start sliding our vertex around, it doesn't matter that it's not at 0, 0. If our vertex is here, we still have the same basic pattern of over 1, 1 squared is up 1. Over 2, 2 squared is 4, go up 4. Okay? And I think we did 7 dots here. On a quiz or a test, we're going to want at least 5 vertex plus 2 on each side, as long as that fits. Sometimes we get a weird problem where 5 doesn't quite fit. 5 is good. 7 is better if you can. Okay, but 5 for sure, unless for whatever reason it doesn't fit on the graph. Okay, so just like what we had up here with our absolute value, it's the same basic setup down here with our quadratics. Okay, inside parentheses slides left and right, and it's opposite of what you want to think. A minus goes to the right, and a plus goes left. And then on the outside, the K goes up and down, and that's normal. A plus goes up, and a minus goes down. And instead of our front multiplier being strictly the slope, okay, because up here it was 2, so it went up 2 each way. It's going to be a little bit different. You're going to go up twice as fast, but because you're not doing the same jump every time, it gets a little bit different. And I'll have a little saying for you to do here, a little trick that'll help, hopefully. Otherwise, we can always fall back on the T-chart. Okay? So minus 3, minus 1. Where is our vertex? That's the first thing we need to do. It's basically the most important thing we need to do. So minus 3 on the inside, minus goes to the right. So we're actually going to go 3 to the right. And a minus 1 on the outside is going to move us 1 down. So the most important part is getting that vertex, 3, comma, negative 1. And if you want to put that in the middle of your T-chart, you can certainly do that. So then we would have 4, 5, 2, 1. Okay, if you're a fan of the T-charts and you want to fill those out, you can. It's slow but steady. Okay, nothing wrong with that. That's how the turtle beat the rabbit in the big race. But I think if we follow the pattern here, we'll get it even faster. So you can do this if you want. Alright, so let's say if I put 2 in. 2 minus 3 is negative 1. Negative 1 squared is 1. Minus 1 is 0. And because we reflect, we can put that 0 there. Okay, 1 minus 3 is negative 2. Negative 2 squared is 4. Minus 1 is 3. And we can reflect and put that over here, and you can do your dots, okay? Or we can kind of just copy this pattern. Over 1, 1 squared is up 1. Over 2, 2 squared is 4, go up 4. Over 3, 3 squared is 9, so go up 9. You can follow that pattern from wherever your vertex is. It doesn't have to be at 0, 0. Okay? So here's my vertex. Over 1, we're doing x squared graphs. 1 squared is 1, so I go up 1. And then you can also reflect it over there. Over 2, 2 squared is 4, so I'm going up 4. 1, 2, 3, 4. And then we can reflect it over to there. Let's see if that worked. 1, comma 3. 1, 3. 2, 0. Boom. 3, negative 1, that was our vertex. 4, 0. And 5, 3. Yep, they're all there. Okay. So whichever way you want to go, if you feel more comfortable with the T-chart, okay, put your vertex in the middle, give me 2 points on each side, draw your parabola. Okay, nothing wrong with that. Slow, steady, safe. Okay? If you want to try to go a little bit faster, you can do the points pattern here that I've been talking about. Okay, and hopefully that works out for you too. So this is basically the same problem with a negative sign in the front. Okay, so we're 3 to the right, 1, 2, 3, down 1. So we're at 3, comma, negative 1 in the middle. Alright, if you want to, you can fill in a T-chart and then just reflect. Let's do this. 4. 4 minus 1, or 4 minus 3 is 1. 1 squared is 1. Negative of 1, negative 1, minus 1 more is negative 2. Put in 5. 5 minus 3 is 2. 2 squared is 4. Negative 4, minus 1 more, negative 5. And then these should flip. Okay, those should reflect over. Let's check out the points pattern, Mr. Handke's points pattern. Okay, well, he said if we go over 1, we're doing x squareds. 1 squared is 1, go up 1. But wait, we've got a negative. So instead of going up, our points pattern goes down. So over 1, 1 squared is 1. If we're negative, so we're going down 1. Okay, over 2. 2 squared is 4. But it's negative multiplier in the front, so we're going to go down 4. 1, 2, 3, 4. And then we can reflect it over. And let's double check. 1 comma negative 5. 1, 2, 3, 4, 5. 2 comma negative 2. Yep. 3 negative 1. There's our vertex. 4 negative 2. 5 negative 5. And now this one's going down. There you go. Not so bad. Turn the page. Okay. Now I'm going to stop doing these, but if you want to, you can go ahead and push pause and do it that way, and then see if it matches up with mine. Okay? So we're going to have our vertex is going to be at negative 4, negative 1. Negative 1, 2, 3, 4, negative 1. Okay? No multiplier in the front yet. I was going to, but then I said, you know what, let's do a regular one first, and then let's do the multiplier. So we'll see how this one's different. So there's no multiplier here. So over 1, 1 squared is 1, go up 1. Over 2, 2 squared is 4, go up 1, 2, 3, 4. And then we can reflect over. Hey, we got room, let's do 3. 1, 2, 3. We're doing x squared graphs. 3 squared is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then reflect that one over. Look at that. We'll do the best we can. Ooh, that's a good one. That's a good one. Okay, did you get the same thing if you did the T-chart? I think so. Here's a fun one. Let's see what happens when we do times 2. Okay? So we're still at negative 4, negative 1. 1, 2, 3, 4, negative 1. Okay, we got a number in the front. We haven't had one of those before. We just had a negative, and a negative just meant let's do our pattern and go down. Now we have a times 2, so you're going to double your pattern. Okay? Again, if you want to, you can do this over here. So if I go over 1, 1 squared is 1. But now we're doubling it because it's 2. So I take that pattern number and times it by 2. So instead of going over 1, up 1, we're going to go over 1, up 2. If we go over 2, 2 squared is 4. And now we double it, because we got a times 2 to be up 8. 1, 2, 3, 4, double it, 5, 6, 7, 8. And then we can reflect these over. Okay, so a times 2 in the front wasn't that bad. It's still our same points pattern. Over 1, 1 squared is 1. You would go up 1. But we have a times 2, so you double it. And we're going to go up 2. Out 2, 2 squared is 4. Normally you would go up 4. But we have a times 2, so we're going to go up twice as much, 8. Piece of cake. Did you get the same thing on the other side if you did the T-chart? I hope so. Guess what? You can also do inequalities. Hooray! You can also do inequalities with these. I kind of trimmed down these graph boxes just so I could get 6 graphs on this side of the page. Okay, so we got to start thinking it's exactly the same thing, but now we're going to add on dotted line, solid line, and do I shade above or below? So we're still just going to go through the same process. No multiplier in the front, nice and easy here. Minus 4. Remember, inside is opposite, so we're actually going to go to positive 4. Minus 5. Opposite, comma, same. Opposite is the inside, same as the outside. Opposite, comma, same. So our vertex should be at 1, 2, 3, 4, comma, negative 1, 2, 3, 4, 5. Okay? No multiplier, so our points pattern. If you don't like the points pattern, you can do your T-chart over here with 4, negative 5 in the middle. We're going to go over 1, up 1. Over 2. 2 squared is 1, 2, 3, 4. We got room, let's do it. 1, 2, 3 squared is 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can reflect over. So all this so far has been the same. This is all the same. And now we have a decision to make. Am I going to draw this with a solid line or a dotted line? Okay, less than or equal to. So that's going to be the solid line. And I think I did the funny, man, that's another good one. I'm killing it on this. Okay, I think I started us off with the funny one just to make sure I didn't forget about it. Okay, just like with the absolute values, everyone always thinks it's inside the V. Okay, and people have the exact same tendency here with parabolas to always think the shading's inside the U. Okay, less than or equal to. So put your pen or your pencil. Well, it's really easy if you just do it on the vertex. Put your pen or pencil on the vertex. Which way would be less? Which way has the smaller y values? Y's that are less than. Down. Okay, boom. Down, down. We're on the outside. We're on the outside. It can be the outside sometimes. It doesn't always have to be inside the U. Okay? Let's take a look over here. Plus 1, opposite, so we're going to go left 1. And then plus 2. Opposite, comma, same, so we got negative 1, positive 2. Oh, Mr. Handke, you didn't leave us much room at all. We're going to go off the graph real quick. We got a negative multiplier, which means we're going down. There's no number, so it's still the same pattern, just that it's going down. So over 1, down 1 instead of up 1. Over 2, down 4 instead of up 4. And we can reflect. Okay. We got room, let's do it. Let's do 3. 3 squared is 9. We have a negative multiplier, so we're going to go down 9. There was 4, 5, 6, 7, 8, 9. I think. If I'm wrong, I apologize. I'm getting old and my eyes start crossing looking at all these grid lines and dots. Okay, less than. less than. So that's going to be a dashed line or dotted line. And my curves continue to be fire. Not as good as the last one. This is a little straight there. Didn't get very curved. Less than. Which way are we going? So put your pen or pencil on your vertex. Which way is less than? Down. 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 Hey, we're inside the U this time. Okay, there it is. You guys are doing good. We're almost done. Stay with me. One last problem. And if you've been doing good with these, this should be pretty easy. It's going to look scary, but it's not that bad. Okay, remember our standard kind of form here. A times x minus h squared plus k. So look at the graph. It's just an equals one. It's not an inequality. Come up with the equation. The vertex is very important. This is called vertex form. The vertex gives you that spot and that spot. It gives you basically the whole thing. Okay? So what are we at? We're at 1, 2, 3 to the right and 2 up. So our vertex is 3, 2. Okay, remember inside here is opposite. So we're going to have x minus 3 squared plus 2. Ta-da! Okay. Now, your A multiplier. Look at your dots. Is there any difference? Is it a normal pattern or is it not normal? If I go over 1, do I go up 1? Yes. If I go over 2, what's the normal pattern? 2 squared is 4. 1, 2, 3, 4. So it's our normal pattern, so no multiplier in the front. If you really want to, you could put a 1, but we don't need to. Okay, so there you go. Let's see how that's different compared to this. I think we start at the same one if I did it right. 1, 2, 3, 1, 2. So we still start at 3, 2. I wanted you to really see the difference here. So it's still 3, 2. So remember, it's opposite inside, x minus 3 plus 2, normal on the outside. Now, over here, we didn't have a different multiplier. It was technically 1 because it followed the normal x squared pattern. Over 1, 1 squared is up 1. Over 2, 2 squared is up 4. Okay? What about over here? Over here, if I go over 1, 1, 2. If I go over 2, we're up 8. That is twice as much, right? Normally if I go over 1, I'm going to go up 1. But this time I went up 2. Normally if I go over 2, we're going to go up 4. But this time I went up 8. So I went up twice as much. So we're going to have a 2 times multiplier in the front. See, that wasn't that bad. You can do it. Okay, we got a worksheet today. If you're in class, we can pick one up from me or the sub or whoever's here. And if you're watching this at home, you can print one off of Schoology or check your email. All right, thanks a lot, kids. Best of luck, and let me know if you have any questions.